Hello all, welcome to video 2 in this series where we look at the 2019 Maths B exam and go through the work solutions. As per the first video, I'll briefly talk about what the question is looking to assess and then I'll go through the solutions. This one I'll hopefully be a little bit quicker than the last one. Right, question 1 is clearly a matrix question. We are looking at some matrix operations, so f minus g, we have f minus g again, which we get to use, but then we have a scalar multiplication by 2. We're going to be finding the determinant, and therefore we'll be able to find the inverse. So some basic matrices skills. So f minus g, we get 2, 4, 5, 2, take away 1, negative 3, pardon me, 2, 4. Okay. And just like I mentioned in the previous video, to do basic addition or subtraction, we match up the cells or the elements of the matrix and subtract them from each other. So we get 2 take away 1 is 1. We do 4 take away negative 3. Got the negative and then the negative there. So that turns into subtraction, addition, so we get 7, 5 take away 2 is 3, and then 2 take away 4 is negative 2. And there is our matrix f minus g. Part B, we have 2 times by f minus g, so this is just a scalar multiplication, so that's going to equal to 2. We've already got it, the f minus g matrices, so we may as well put that in. Negative 2, and then scalar multiplication, we just multiply the 2 by everything inside the matrix. So we get 2, 14, 6, negative 4. Happy days. Determinant of f, so the determinant is the main diagonal, so I call this one the main diagonal. You multiply those two numbers together, then you take away the alternate diagonal multiplied together. So determinant of f is equal to 2 times 2, take away 4 times 5, that gives us 4, take away 20 is negative 16. Since that does not equal 0, that means the inverse of f does exist. So if the determinant was equal to 0, then the inverse doesn't exist, but the inverse will, so that is equal to 1 on the determinant of f. And then the matrix, and then same thing like I mentioned in the previous video, you'd switch the main diagonal values, so the D and A gets switched around, and then the other diagonal just gets made negative. The numbers stay in the same spots, but they get switched. So we get 1 on negative 16 times by 2 and 2, and then negative 4 and negative 5 equals, well, it's not great for simplifying. We're still going to be left with a fractional answer, but you always want to simplify it where possible. So we multiply the 1 on negative 16 through everything, so 2 over 16 turns into negative 1 on 8. Negative 4 on negative 16 turns into 1 on 4. Negative 5 on negative 16 just stays as 5 on 16, and then 2 on negative 16 turns into negative 1 on 8. And there is our inverse. Right, question 2. Question 2, solve the following quadratic equations. Okay, we are solving here. So this is looking at, there's going to be a couple of things tied in here. We need to be able to factorize. Because they are quadratics, we want to factorize, and then we're going to use them. Pretty much always we'll use the null factor law where possible. So the first one is x squared plus 4x plus 4, looks like a standard quadratic. The x squared has no, the coefficient is only 1, so we're just going to have a go at factorizing this via inspection. So I need two numbers to multiply to give me 4, and then those same two numbers add to give me 4, which is pretty easy. That's just going to be 2 and 2. And because we are solving and not just factorizing, we want to make sure we write this out properly, that it is equal to 0. And we can use the null factor law, which says that if we have two brackets multiplied, or any two terms or two whatever they are expressions that multiply together and they give 0, well then one or the other must equal to be 0. So we can follow on and say that x plus 2 must equal 0, or, and we've got a repeated bracket, but I'm just going to write it for full working out just so you can see. You wouldn't have to do both of these because they give the same number, but just so you can see it. So we get x is equal to -2, and we get the same thing, x equals -2. So that second one we can just ignore because it's exactly the same. Part B, saw a lot of people get sort of hung up on this, trying to factorize. Whenever you see a problem that requires you to solve, which normally then infers you need to factorize, but if you have any problem that involves any sort of factorization, the very first thing you should do is take out a common factor. That will normally make your life a whole lot easier. So in this case, I can actually take out x as a common factor, so I get x times by x plus 1 is equal to 0. And it might not look like it, but it could also be written as that, where we put that first x in the brackets. Now, as soon as we see it as x in a bracket, x plus 1 in a bracket, we can see we get to use the null factor law again. So we get x equals 0 or x plus 1 equals 0. So we still get x is equal to 0 and then x is equal to -1. Just to show you what some people do, they get the x bracket x plus 1 equals 0, and then they go, well, I have x plus 1 left, 0 on x, divide both sides by x, and it will disappear, so I get x plus 1 is equal to 0, and so I get x equals -1. So we get one of the correct solutions, but because you do this divide by x here, you actually lose one of the solutions. So we see a lot of students do this answer and you only get half a mark because you've only found one of the solutions. You need to realize that if we use the null factor law straight away when we factorize, we actually can see that if I let x equal 0 is also a valid solution. Right, next one, 4x squared plus 6x equals 18, so it doesn't directly equal 0 straight away, so we need to change this into 4x squared plus 6x minus 18 equals 0. Now we've got something equals 0. If we factorize it properly, we get to use the null factor law. Same thing, the very first thing I should try and do when factorizing is take out the common factor. So I get 2 bracket 2x squared plus 3x minus 9 is equal to 0. We get 2 bracket, and this one we have a coefficient. Let me do some erasing so quickly. We have a coefficient in front of the x squared that is not 1. We have that there, so that means we either need to use, we have to use the cross method or we use the quadratic equation. But we will use the cross method here. Okay, so to make a 2, it needs to be a 2 and a 1. To make a 9, it's either going to be negative 9. It'll be a 9 and a 1 or a 3 and a 3. I'm going to take a guess and think it's a 3 and a 3. So I put those in. Now I need to make a positive 3 all up. So 1 times 3 is 3. 2 times 3 is 6. I need to make 3. So I'd make this top 3 negative because it was a negative 9. So we get 2 times 3 is the 6. Put my x's in there. 6x gives me negative 3x. Add those together, gives me 3x, which is the middle term, which works. So I can now say that we get 2x minus 3 is the first factor, x plus 3 is the second factor, is equal to 0. So we can, again using the null factor law, now say 2x minus 3 equals 0, or x plus 3 is equal to 0. So we get x is equal to, add the 3, then divide by 2, we get 3 on 2, or we get x is equal to negative 3. So same thing again, we get two solutions. Question 3. Okay, state the number of solutions these quadratic equations using the discriminant or otherwise. So just the discriminant, just a reminder, we normally use the triangle symbol, is equal to b squared minus 4ac. And if the discriminant is greater than 0, we get 2 solutions. Well, I cannot spell today. Solutions. If the discriminant is equal to 0, we get 1 solution. And if the discriminant is less than 0, we get no solutions. So that's what we're doing here, is just remembering that formula b squared minus 4ac, which makes up part of the quadratic equation. And we're going to use that to check how many solutions these answers have. So let's have a go. It also helps to write these in the form of a regular quadratic. So with three terms, so we could say that this is the same as 4x squared plus 0x plus 3, because we're missing that sort of middle term, is equal to 0. So we get a is equal to 4, b is equal to 0, and c is equal to 3. So follows on, the discriminant is equal to 0 squared minus 4 times by a, which is 4, times by c, which is 3. So I get 0 squared take away 16 times 3. 8, carry the 1, 3, 48. So we get negative 48. Okay, so since it's negative 48, we need to write the final answer. We need to make sure we're answering the question, state the number of solutions, therefore we get no solutions. Okay, this one is not written in standard quadratic form because we have it equal to 4, so we need to move that 4, so we now get 5x squared plus 3x, take the 4 over to the other side, that turns into negative 2 is equal to 0. Now it's equal to 0, we can use the discriminant properly. So the discriminant is equal to 3 squared take away 4 times by 5 times by negative 2. So we get 9 plus 20 times 2 is 40, is equal to 49. Therefore, since it's greater than 0, we have 2 solutions. Lovely. Okay. A letter from the word Teddy is selected twice without replacement. Fill in the table representing the outcomes below. Okay, so we have T, E, D, and I'm going to put a 1 there, a D2 since there's 2 D's in it, Y, T, E, D1, D2, Y, and then I now need to start filling the rest of it in. So we get TT, ET, T, and just bear with me, I'm going to take about 30 seconds to fill this in. Y, E, almost done now. Y, D, Y, D, Y, Y. Okay, now why I put that D1, D2 up here, D1, D2, D1, D2 is because they're technically different Ds. It would be like if you had 2 blue pens, even though they're the same color, they're technically 2 pens. So even if you do without replacement, so say if I pulled out D1 first, out of my bag or out of the hat or whatever, there's still D2 sitting inside it. So if I fill this in properly, so that's D1, D1, that's D2, D2, but this is D2, D1, this is D1, D2. So it's without replacement, so TT we can't get, EE we can't get, D1 we can't get, D2 we can't get, and YY we can't get. But the D2, D1, this one here and this one here, they're still allowed because they're technically different Ds. So that still works. Okay. How many ways are there of selecting a D and then a Y? So getting a D, then a Y. We have D, Y down here, down there. There's 2 ways. Okay. What is the probability of selecting a vowel? Okay, so a vowel, for those of you who can't remember, is A, E, I, O, and U. In our case, it's just the E's. So we have, let's circle in black. We have E, 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 E. Okay, so how many is that? That's 1, 2, 3, 4, 5, 6, 7, 8. So we have a probability of a vowel is equal to 8 on total sample space is 1, 2, 3, 4 on 20. 8 on 20, we want to simplify that. So that's the same as 4 on 10, which is the same as 2 on 5. So the probability of getting a vowel is 2 on 5. What's the probability of selecting a consonant given a D is selected? Okay, well, this is a good question. So this is a given. So since we have a given, that's a conditional probability. So we're asking what's the probability of selecting a constant, which we'll call C. So constant is anything other than a vowel. Given a D is already, given a D is selected. Okay. Right. Okay, so let's see if I can do some arrays in here. Just to make it a little bit easier. Okay. So we could use the probability formula, which is probability of the conditional probability is equal to the intersect of the two divided by the probability of the second one. But that requires a bit of counting. It's much easier, like I explained in the first video when we have conditional probability, is think about how it changes the sample space. So we have a restriction, given a D is selected. So that means we have changed our sample space. Okay, where we're only allowed things that include a D in them. So we can cross that off, cross that off, cross. Okay. That is it. Okay, so all that's left. Now there's a little trick in this problem, it's really annoying, but if you look at all of them, you'll count what's left after crossing off anything without a D in it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12. Okay, so I'm not using this formula at the moment, I'm just looking at it by reducing the sample space, only allowing ones that have 12. So there's 12 boxes that have a D in it. Now how many of those have a consonant? Well, a D is a consonant, so that means every single one of them, because we have to have a D, already has a consonant in it. Doesn't matter what the other letter is, so it's actually 12 out of 12, so it's equal to 1. Because a D is being selected, okay, as one of the two letters, means every single one's going to have a constant. I miscount, I forgot the double up of the D's, that's 14 on 14. But the answer comes out to be a 1. Rightio, question 5. Consider the following composite shape. Calculate the perimeter of the composite shape, giving your answer in exact form. Part B, calculate the area of the composite shape, given the area in the exact form. Okay, so what is this problem looking at assessing? Well, dealing with composite shapes, measurement of composite shapes. How can you break them down? So let's have a go. And with all composite shapes, there's multiple ways of doing it. how you could break it down, how you interpret it. Like, so straight away I could see that if I took this bit here, and if I was looking at the area bit, I'd notice both of these are a quarter of a circle. So instead of finding the area of 2/4 of a circle, I'll just join them together as a half circle and find the area of half the circle. So there's many ways to go about it. So what I'm going to show is just one way, but it at least gives you an idea. So I'm doing the perimeter first. So straight away we can see that that's 4, so that's 4 over there, that's 4 there. Okay, so I'm going to have those two bits. What does that leave this length here in blue? Well, if that's 4 there, that must mean that's 6, so we can add them together. So our perimeter so far is 2 times 6 plus 2 times 4 plus we have to get these red bits. Right here, so the red bit, there's 2 of them, so straight away I'm going to put 2 times. Now we need to realize that that's part of the outside of a circle, and what is it? It's a quarter of a circle. So a single red bit is equal to quarter of the circumference of a circle, or C. So I'll say that again. The red line here, just at this point, that is equal to quarter of the circumference of the circle. So that will equal to quarter times by 2 pi r, which is equal to, simplify the 2 over the 4, that becomes half pi r. Now the radius of that circle we can see is 4 centimeters, so that's equal to half pi by 4. So that simplifies again, half by 4, that gives us 2 pi. So the length of one of those red lines is 2 pi. So we can fill that in. So now I can say that my perimeter is equal to 20 plus the 2 times the 2 pi gives me 4 pi. And that's an exact form. If you came up with this a different way, you would need to keep simplifying to ensure you get the same answer. Rightio, part B, calculate the area of the composite shape giving answer in exact form again. So we're not going to, we need to have the final answer with pi in it again. So the area is equal to, like I said, that's a terrible shape. One part of the circle plus the middle rectangle plus the other quarter of the circle. So the area of that is a quarter of a circle, so pi r squared, plus the area of the rectangle, which is just 6 times 4, plus the area of another circle, which is pi r squared. So we get, the radius was 4, so that's 16, so we get 1 on 4 pi by 16 plus 24 plus same thing again, 1 on 4 pi 16. Now the 16 divided by 4 is just 4 pi plus 24 plus 4 pi again. Now the 4 pi plus the 4 pi, we can add them together, so we get the area is equal to 8 pi plus 24, and I've left off units. So I made a mistake in that previous answer because I was giving units that the perimeters in centimeters, so that's centimeters. Area, that'll be centimeters squared. That's how you do it. Again, like I said, you could have instead realized that those 2 quarter circles could have been joined together and equal half a circle. Maybe saved a little bit on working out, but up to you. Question 6, solve the quadratic 2x squared plus 4x minus 3, giving answers in exact form. And I have to do it 2 different ways. I have to, 1, use the quadratic formula, and then 2, I need to do it completing the square. So quadratic formula says that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Where 2 is our a, 4 is our b, negative 3 is our c. So we're just going to substitute those in. So we get negative 4 plus or minus the square root of 4 squared take away 4 by 2 by negative 3, all divided by 2a, which is 2 times 2. So we get negative 4 plus or minus the square root of 16 plus, because negative 4 times negative 3 is positive 12 times 2 is 24, divided by 4, that gives us negative 4 plus or minus the square root of 40, divided by 4. We can simplify the square root of 40 is the same as square root of 4 times 10, which is equal to 2 root 10. So we get negative 4 plus or minus 2 root 10 on 4. We can take out the which we could take out 2. We can simplify the fraction a bit. We could then say that's the same as negative 4 on 4 plus or minus 2 on 4 root 10, and just changing the denominator, changing the two terms in the numerator into separate terms over the denominator, which gives us negative 1 plus or minus half root 10. So that's using the quadratic formula, and I've left the answer in exact form. Root 10 I can't simplify any further. Now completing the square. Takes a bit of working out. We have 2x squared plus 4x minus 3 equals 0. Now there's a rule for completing the square. The rule for using completing the square is the coefficient of the x squared term needs to be 1. We can't have this 2 here. So the way we get around that is by taking it as a common factor. So we get 2x squared plus 2x minus 3 on 2, since we're taking it as a common factor, equals 0. Now we can do completing the squared of this bit in here, being careful not to forget that 2 later on. So we get 2 bracket x squared plus 2x. Now we need to use our magic number. So our magic number comes from the 2x. We halve the 2, then square it. So 2 divided by 2 is 1. 1 squared is 1. So we write plus 1, take away 1, take away 3 on 2. Equals 0. So we now get 2. The x squared plus 2x plus 1 can be written as x plus 1 all squared. And then we get negative 1 take away 3 on 2. So negative 1 take away 3 on 2 is the same as negative 2 on 2 take away 3 on 2 is equal to negative 5 on 2. We get minus 5 on 2, close bracket, equals 0. So now we get 2 bracket. Now we have x plus 1 all squared take away 5 on 2. We want to write that as the difference of perfect squares. So we get root 5 on 2 all squared is equal to 0. So we get 2 bracket x plus 1 minus root 5 on 2, close bracket, bracket x plus 1 plus root 5 on 2, close bracket, equals 0. So we're slowly getting there. So we can now say that x plus 1 minus root 5 on 2 is equal to 0, or x plus 1 plus root 5 on 2 is equal to 0. So we get x is equal to negative 1 plus root 5 on 2. And this will be the root of the whole thing. Or negative 1 minus root 5 on 2. And that should be equivalent. Let's do a quick check. Because I could write that the same as, so root 5 on 2 could be written the same as 5 times 2 on 2 times 2 is equal to the square root of 10 on 4 is equal to the square root of 1/4 times by square root of 10. Square root of 1/4 is just half, so we get half root 10. So this plus 5, the square root of 5 on 2 is exactly the same as square root half times by square root of 10. That's what we've just shown here. So we should get the same answer, which we have. They just appear in different forms. But that's the answer. Right, question 6. Calculate the volume of this composite shape correct to 2 decimal places. Okay. First hint, as soon as we see that we're not answering in exact form, and we're told how many decimal places are, is keep as many decimal places, keep a reasonable amount until the very final answer. If you start rounding too early, you might end up getting the wrong answer. So that's just my biggest hint. So volume, volume is equal to the volume of the cylinder plus the volume of the half sphere on the top. So that is going to be equal to the volume of the cylinder. If we go all the way up to our formula sheet, volume of a cylinder is pi r squared h equal to pi r squared h plus the formula for the volume of a full sphere is 4 on 3 pi r cubed, if I remember correctly. Let me double check. Volume sphere 4 on 3 pi r cubed, correct. Okay, but we only have half of it, so we put a half in top. So we can now just start filling in everything. So we get pi times by the radius is 3 squared times by the height of the cylinder is 7 plus half by 4/3 pi times by 3 cubed equals, and then we're going to stick it in our calculator and get the answer. So give me 1 sec. Pi times by 3 squared times by 7 plus 5 times by 4 divided by 3 times by 3 to the power of 3 gives me 215.92, and the units we're given is centimeters, but we're doing volume, so it'll be centimeters cubed. There we go, there's our answer. Now if you had found, what I was saying before is some people may have just found the cylinder by itself, then just the half sphere by itself, rounded them, then added together, and because you maybe rounded early, it shifts the final answer, so you want to be careful of that. That's why I sort of make this giant equation first by itself. Right, part B, calculate the total surface area of this composite shape. Correct the 2 decimal places. Right, so surface area of this problem, and you'll even see volume was only 2 marks while surface area is 3. Surface area of composite shapes is a little bit harder because same thing, the total surface area is equal to the cylinder, okay, but we need to not count the top bit there because that's where the sphere joins on, plus we need the surface area of that half of the sphere. So the sphere bit's easy, it's just half of the surface area of a sphere is equal to 4 pi r squared r squared. So that gives us the surface area of that top bit. Now we just need the cylinder. So surface area of a cylinder is, there we go, here it is, 2 pi r h plus 2 pi r squared. 2 pi r h plus 2 pi r squared. Okay, now let's break down this cylinder formula and make sure we get it correct, because as I said, we can't have this top bit, that top circle isn't included. Okay, that actually isn't in there, so we don't need that in the surface area. What this formula is this is the end caps, okay, which is the top and bottom end caps, which is that and that bit, and then the 2 pi r h, if you remember the formula, that's what we call, I guess, the wrap, which is the bit that goes all the way around. Okay? It's the curved bit that goes all the way around the cylinder, all the way around on the back side as well. So we only want one of the end caps. We want the bottom one, but we don't want this top one. So at the moment you can see it's 2 pi r squared because it's 2 end caps. So we don't want that second end cap. So now we have our correct formula, which is equal to 2 pi r h plus pi r squared plus half of 4 pi r squared. So we can put in all our values. So we get 2 pi times by the radius was 3 times by the height is 7 plus pi by 3 squared plus half by 4 by pi by 3 squared gives us a final answer. Stick it all in the calculator. 2 times pi times 3 times 7 plus pi times 3 squared is 9 plus 0.5 times by 4 times by pi times by 3 squared again is 9, so I'm going to stick a 9 in. I get 216.7698 blah blah blah, which is equal to 216.77. I have to round up, and units are centimeters, and because I'm doing surface area, it'll be centimeters squared. So that is question 7. Right. Question 8. A survey of 121 people showed 65 liked pizza, 54 liked pasta, and 45 people liked both. If A is the event likes pizza, B is the event likes pasta. So I'm just going to put that here, pizza up here, pasta over here. Fill in the following two-way table. Okay, 121 people total. Okay, we have 45 people that like both. We have 65 people total that like pizza. And we have 54 people total that like pasta. So we get that over there. And we can now start filling in the rest of it just as a normal two-way table. So purple is what we got from the information, the rest in blue is what we have to figure out. So 45 to 65, that has to be 20. 45 to 54, that's going to be 9. 65 up to 121. 121 take away 65 is 56, that needs to be 56. 121 take away 54 is 67, so that has to be 67. And 56 take away the 9 is 47, which we'll check now across going that way. 20 plus 47 is 67, so that works. That works, that works, that works, that works. So it all works. Use the two-way table to answer the following answers in exact form. What's the probability of B? Okay, well, that is equal to 54 over 121. Can that simplify quickly? The way to check, because it's tech active, was I just put 54 divided by 121 in your scientific calculator and then hit the S arrow D arrow key, which is just above your delete button normally, and convert it to fraction, and it'll give it to you in most simple fraction, which still happens to be 54 over 121. So that's easy. Probability of B given A has occurred. Okay, so this is one of those given ones. You could use the formula, but again, I'm a big proponent of looking at it from a, I guess, logical or an intuitive standpoint. So given A has occurred, that means all of this is ignored. So our total sample space, now we only have a total of 65 people we're dealing with. How many of them are in B is 45. So I get 45 over 67. Over 65, sorry. Now simplify, I can divide both those by 5, so I get 9 on 15. I can divide both those by 3, so I get 3 on 5. So the probability of liking pasta given that they like pizza is 3 out of 5, not bad. Probability of not B intersect A, okay, so let's delete some of these lines. Probability of not B and also being A means we end up here is 20 over 121. And I'm pretty sure we can't simplify that either, but I'll double check. No. Done, done, done. So what was this question assessing? Well, it's breaking down two-way tables and then using a two-way table to calculate probabilities. Question 9, second last question of this video. I'm going to do questions 1 through 10 in this video. Find the value of A in the following quadratics if only one solution exists. So what is this doing? This is testing us on using a discriminant. Because we're told there's only one solution exists, we must know that the discriminant must equal 0 for only one solution. So we will use that to calculate what A is. So our discriminant is equal to, and our discriminant is going to be equal to B squared take away 4AC. And this is really odd, is that we have A, which is from our sort of standard form of a quadratic, but there is also A's in these as the unknowns, where this one over here, that's in the normal position, so A means A, but this A here is actually holding the place of a constant, sorry. So that's actually part of C, which is a little bit, that's quite a tricky question, but let's get into it. So the discriminant for this one is equal to, well, it's a 1 in front of that x, so it's 1 squared take away 4 times by A times by 1 times by 1, and we're going to let that equal 0, so we get 1 take away 4A is equal to 0, so we get 1 is equal to 4A, so A must be equal to a quarter, just using algebra. Rightio, part B, this does not equal 0 yet. We need to make it equal to 0 to be able to use the discriminant or the quadratic formula, so we need to rearrange this and get it looking like a normal quadratic. So we normally start with our x squared plus our 5x plus our, and I'll put in brackets just so it's a little bit more obvious for you, we get our A plus our 1, take away our 3, because I'm going to take away 3 from both sides, is now equal to 0, so I get x squared plus 5x plus A minus 2 is equal to 0. So we have a 1 in front of the x squared, so our discriminant is equal to 5 squared take away 4 times by 1 times by, in this case we have A minus 2 as our whole constant at the end. It has no x associated with it, and because we've got one solution, that discriminant must be equal to 0. So we get 25 take away 4, A minus 2 is equal to 0. So we get 25 is equal to 4A. I'm jumping too many steps here for you probably. I'm taking this whole negative minus 4A minus 2 to the other side, so we get 4A minus 2. So we get 25 is equal to 4A take away 8, so we get, add the 8, that's 33 is equal to 4a. Coming in here, we get a is equal to 33 on 4. And that'll make sure that quadratic only has one solution. Finally, question 10. 3 multiplied by the sum of two numbers is 5. 5 multiplied by the first number subtracted from the second number is 7. Represent both these numbers as two simultaneous equations, and then as we go on to the next page, use the matrix method to find these two numbers' answers in exact form. So what this is assessing is the ability to make simultaneous equations from a worded problem, which is sort of actually just assumed knowledge. We didn't spend much teaching this. This is from previous years. And then part B is sort of the new Year 10 Maths B coursework, which is solving two simultaneous equations using matrices. So let's build these simultaneous equations. We have 3 multiplied by the sum of two numbers. So I'm going to let number 1 equal to A, whatever it is, and number 2 is equal to B. Actually, no, I'll choose X and Y, just because that's probably what we're used to doing inverse matrices. X and Y. So 3 multiplied by the sum of two numbers. So we're going to go X plus Y, which is the sum, means plus. Multiplied means, of course, multiply, is 5. And then 5 multiplied by the first number, which is X, subtracted from the second number is 7. So you have to be a bit careful in this. So we're 5 multiplied by the first number, we're then subtracted from the second number. So whatever this first bit here is we're then taking away from the second number. So we actually have to do y minus 5x is equal to 7. So if you read that sentence again, it hopefully makes a little bit more sense now. 5 multiplied by the first number, which is 5x, is subtracted from the second number. So we're taking 5x away from y. And that gives us 7. I'm going to fix these up a little bit to get them looking like standard equations. So I get 3x plus 3y is equal to 5. And I'm going to write negative 5x plus y is equal to 7, just to get the numbers in the variables, the x and y's, in the same positions, because they need to be in the same position, as in x is in the first term, x is in the first term, y is in the second term, y is in the second term. You need that order to be held to be able to solve these using matrices. So what do we get from this? Well, from those above two equations, we could write that as a matrix where the first matrix is our coefficients, 3, 3, negative 5, 1, multiplied by a matrix that has our variables in it will equal 2, 5, and 7. So we get that. So we have A, X equals B when we write matrix form. So we have A times X is equal to B, where our matrix X has our unknowns in it. So we want to figure out what this matrix is. Now, using matrix operations, we can multiply both sides by the inverse of A. Okay, sort of like just doing algebra. So multiply that by the inverse of A, multiply this side by the inverse of A, and we are left with X is equal to the inverse of A times by B. Okay, so if we do inverse of A times by B, we will find out what X is. The key thing to note here, some people do it as B times by the inverse of A. That is wrong. You need to put the inverse first. So we get X is equal to, we need to find the inverse of A before we do anything. I jumped the gun there. So inverse of A is equal to 1 on the determinant of A, which I've done a couple times now, so I'm not going to spend much time. We get 3 times 1, take away 3 times negative 5. I get 1, 3, negative 3, positive 5 by switching the sign. So we get 1 on 3 times 1 is 3. Take away, that's going to be a plus. 3 times 5 is 15. 1, neg 3, 5, 3. So that gives us 1 on 18. 1, neg 3, 5, 3. Yeah. I was just checking to make sure I copied my equations properly down first. So there's my inverse. So we can now say that x is equal to 1 on 18, bracket, 1, neg 3, 5, 3, bracket, bracket, 5, 7. Now you could multiply the matrix, the fraction, we could multiply that fraction in and then try and do a whole bunch of fraction operations, but I suggest leaving it to the end to make life easier. So we get 1 on 18. We're going to do this matrix multiplication here, so we get 1 times 5, so we get 5, take away 21. Over 5 times 5 is 25. 3 times 7 is 21, plus 21. So we get 1 on 18, bracket 5, take away 21 is, get my brain to work, 16. 25 plus 21 is 46. Now we can finally simplify. We get 16 on 18, I'm running out of room here, 46 on 18. Gives me, simplify that first one, divide both by 2, is 8 on 9. That second one, I can divide both by 2, gives me 23 on 9. And that's solved. I would suggest, if you had time, depending on how you're going, you could substitute these two numbers back into these original equations to do a check, to make sure you get the right answer. But this video's gone on for 52 minutes, which is way plenty long. So the next video will have questions 11 through 18 in it. As a quick reminder, like the previous video, this test, you have 90 minutes of writing time. It's a total of 85 marks. That means you're doing close to 1 mark a minute. So this first 10 questions you probably have wanted to actually do in about 45 minutes, not 50 minutes. That's it for now. Thank you very much. The next video will be out shortly.